Hello everybody, this talk is science-fictional user interfaces. Since we normally only get to talk about topics related to machine learning, programming and simulation, it's pretty exciting to be at a very serious data conference to show you lots of pictures of science fiction. This is us. The lovely Dr. Paris is a game developer and a researcher in computer science and human-computer interaction. I'm a grad student, a data scientist and a programmer. We're both passionate sci-fi fans, as you can see in a picture from a Star Trek cruise we went on earlier this year and have already booked for next term. Together we're part of the team writing Practical AI with Swift, which comes out later this year, and Paris and his team have written more than 25 books on iOS, Swift, game development, literal rocket science, and more for O'Reilly and for dummies over the years. Paris' team at Secret Lab is also known for their work on the game Night in the Woods, which won a BAFTA last year, among many other awards. This talk topic will intersect a bunch of things: UX, HCI, design, sci-fi, film industry, and it's nowhere near the amount of depth that we could go into if we had more time. Much of what we're talking about here can be found in books and papers like these, some of which we wrote, most of which we did not. This is a very, very good book in the front that we had to purposely not read much of. We are not the only technologists talking about this, basically.
So, why are we here talking about a silly topic beyond the obvious fact that we're enormous geeks? We really think there's something to learn here, but most of the narrative about science fiction in the real world tends to break down into this. It's along the lines of, in the 60s, Star Trek had a flip communicator. Then we had flip phones. Isn't that neat? It's generally what it boils down to. It's about as in-depth as it gets. The usual conclusion is, isn't Star Trek neat? And people move on and go about their day. If the narrative gets a little more in-depth, you might find people pointing out that Star Trek had flip communicators. The first flip phones flipped the other way, and then they swapped to flip like Star Trek, and they became better, and it gets a little bit... Really, it doesn't get much deeper than lots of common technology kind of existed in some form in Star Trek or sci-fi or whatever, and people don't really look at it with any more depth. So before we get into, hopefully, a little bit more depth, we'll like to tell you a story. It's not big data or AI, but it is science fiction. In 1892, there was a man named Simon Lake in Pleasantville, New Jersey. He designed and then shortly after built a submarine named the Argonaut Jr. for the US Navy. That's the wrong slide. Why has it done that? For the US Navy in response to a tender. It turns out when he was a kid, about 10 years before that, he had read 20,000 Leagues Under the Sea by Jules Verne, which was a very influential science fiction novel, and decided as a child that he absolutely must build a submarine like the Nautilus from that book. So when he got the chance to do that, he did. He built a submarine, and it was the first to successfully operate in the open ocean, and it became the template for which all modern submarines were built. He even got a telegram from Jules Verne himself, congratulating him on building the Nautilus, effectively, which he kept and is now preserved in a museum somewhere. It's a really great inspirational story about why science fiction can impact the real world, and we just really love this story. Fast forwarding a bit, and again, this is just not changing slides. I'm going to do this again. I don't know why this was doing this. This is another example that we really love. This is a table that was shown in the first X-Men movie. Okay, so back in 2000, and at the time, a man named Doug Caldwell in the US went to the movies with his son. The story goes he went reluctantly to the movies with his son, and he saw this table in the X-Men movie. And when he got back to work the next day, he set to work orchestrating a real-world project to build this table, because he saw this table in the X-Men movie, and it turns out that Doug worked at the US Army Topographic Engineering Center, where their job was to help build things like sand tables, which are named after literal sand tables, which used to be used by generals, you know, when you poke around sticks on little models or build mountains to show terrain. His job is to represent data to the army in terms of ground engagements. And he saw this in the X-Men movie, and it was not something that existed in the real world, and he decided it was perfect for his work. So he wrote an RFP, which ended up going to a company called Xenovision, and they built a better version of the X-Men table that actually exists in the real world now. It's called the Xenovision Mark III or something. More interestingly, the RFP was basically just a copy of X-Men attached to an RFP document. They literally included the movie and said, please build this table. They ended up with something that was better. It's fun to see how science fiction inspires the real world. Of course, many science fiction user interfaces are absolutely dreadful. This is from Star Wars Episode 1. This is a button in Queen Amidala's ship, you know, the big shiny metal ship. This button does anything it needs to do. This button does intergalactic sat-nav, it starts a holocall, it lands the ship, it does a whole bunch of other things in the movie. We don't think this button is some sort of magical, contextual, predictive UI. We just think this button is lazy production design. It's a great example because it's, you know, Star Wars looks amazing. but it doesn't necessarily work amazingly. Many science fiction designers who'd work on films explicitly get into this industry because they want to avoid having to deal with such pesky concerns as user experience. They don't like those things, and many sci-fi UIs are actually pointedly baroque. They deliberately become weird just to avoid it. So basically, within the constraints of what we've just talked about, science fiction can actually show us what's possible when you're unconstrained by technology. It's really powerful, but we're not sure if this can be broadly useful. The last few stories are really good anecdotes. They're fun. People are individually inspired by science fiction all the time, but is there something more systematic to be learned about what sci-fi does? This talk aims to answer some of those questions if we can. We've only got 40 minutes, so this is just a taster. We hope you enjoy it. It's a bit different to your typical Strata session, so we're happy to be here.
Before we start, we need to quickly touch on what we mean by science fiction. We're happy to accept anything as science fiction, if it's on film, TV, comic books, video games, printed. It's all inspiration for real-world work, after all, but we're mostly talking about visual sci-fi today, just because it's easier in a conference talk format. We're basically talking about everything since this film, the French sci-fi, in English called The Voyage to the Moon, from 1902, believe it or not. Many might have seen this before, obviously colorized in the film clip we're seeing here. This is one of the first, if not the first, sci-fi films ever. And it basically has no interfaces or controls of any kind. To open the rocket door, you push it open. It's a product of its time, the industrial age paradigm, where things were done with physical force. It had very little abstraction. But it sparked something, and from the 1920s and 30s, it gets interesting very fast. Sci-fi happened. We're explicitly not talking about sci-fi where it veers nearer to steampunk or fantasy, though they are interesting. The purpose is not to examine plausible futures for us living today. Maybe a topic for next year. We're also not talking about the super abstract stuff, as James was talking about in his amazing keynote this morning. That was so good. That type of sci-fi, mostly novels with worlds where the technology is so advanced that it's invisible or requires no interface at all, where it's entirely responsive to anticipated needs. We're going to stay away from that, and we're going to stay in the realm of things where we could feasibly implement them without changing society entirely. So let's quickly define what we mean by interface also. We don't want to go down an academic rabbit hole, so we're going to keep it simple. Our definition of an interface is basically the intersection of all these things: input, output, industrial, interaction, and information design, purposely very broad. And these are the key things we're going to focus on across the rest of our talk.
We were originally going to theme the whole talk like Star Trek, but we decided that's too hard to read, so we didn't. So to aid our discussion of how science fiction is useful to real-world work and making good interfaces for all the sorts of huge problems, big data, AI, AR, AI, all the stuff we do every day, we've kind of grouped sci-fi into some themes, some eras, so you can kind of think about how they fit in to where they sit in the world. And this is not something that is existent in much media. Some people have kind of done this, but we've just made these up. This is not like a predefined set of categories that anyone really uses broadly. This is just something we've identified. There's a huge amount of science fiction out there, so we're not going to cover everything. We're not going to cover everything that you love. We might cover some of them, so I'm sorry if we skip something that you really love. Please let us know. Please tweet at us if there's some sci-fi or sci-fi UI we should check out. It's really one of our favorite things to look at. One of the books we mentioned earlier, and we'll provide some links to the books at the end of the talk, did a bit of a study doing some qualitative analysis, some grounded theory type work on the themes found in science fiction UIs. And they came up with this word cloud, which broadly summarizes everything you can find in sci-fi and how prevalent it is. Some of this is pretty predictable, like glow and blue and red and screen. Some of it is more interesting. So today we're going to go through some of the things represented here. I'm going to start with an era that we like to call knobs and dials. So is knob a thing in Britain that I can say? I don't know. We normally speak in America and Australia. Australians will laugh at that. Americans just stare at you. Britons assume we're like Australians, right? You're going to laugh at it? Yeah, okay. It's literally just mean a knob and a dial and a button. It's not anything silly. Following the Voyage to the Moon, the French movie we looked at a minute ago, electricity began to be everywhere as well. Mechanical controls started to appear in consumer goods, appliances and things like that, and that started to filter to sci-fi. And then from sci-fi, that filtered back into the real world, and that filtered back into sci-fi, and so on and so on and so on. Lots and lots of appliances in this era started appearing and looking very futuristic, which had a real big impact on science fiction. Because in this era, almost everything in the real world was starting to be very mechanical, very industrial. And this had profound effects on science fiction. Film itself was very new at this point, so there's not really established conventions or rules on how to show an audience something or make an audience understand something. But that also meant there's no platform for understanding what something is or how it works. Science fiction was basically a clean slate. You had to show the future somehow. How did you do that? You used the most futuristic thing around and then maybe added a little bit to it. The best and most quintessential sci-fi example, I'm sure all of you have heard of this film, you've not seen it, in this early knobs and dials era is Metropolis, the German expressionist film from 1927, believe it or not, which shows control panels full of physical controls, mechanical knobs, dials, all over it. This kind of set design dominated in the 20s, 30s, and 40s. It's basically set decoration. The dials are there for decoration. It looks good. It looks industrial. It looks complicated enough to make it feel futuristic. It's very much rooted in what people knew. People had radios, industrial machines, electricity. They kind of knew that this was scientific, futuristic technology, but it doesn't need to work or make sense. It just looks impressive and futuristic, okay? So this is not very interesting to our analysis of what could be useful. There's sometimes some more thoughtful things. This is also from Metropolis. This is a video phone system. This is tremendously futuristic, really. This is one of the most interesting things Metropolis showed. This guy checks his ticker tape to see if he's got any messages, then he doesn't, so he makes a video call. He does all sorts of interesting things that very much resemble modern interactions. This is 1927. This is ridiculous, right? The director could have very easily made some stylistic decisions and shown this quite differently, just like showing them talking directly to camera, but he instead shows us how the machine works, and nobody had ever seen anything like this at the time. So this very much set the tone for how video phones might work in the future, and interaction designers who actually worked on video phones in the 40s and 50s 100% looked at this. There is a UX technique called body storming, which is kind of related to this. So if you're interested in prototyping the future, when it doesn't exist, look up body storming. It's really interesting. But again, this is still mostly set decoration. It's not actually super practical.
But within the realm of knobs and dials, there is a clear distinction where the knobs and dials suddenly became useful, more contextually interesting instead of seemingly random or artistically placed set dressing. Because in the real world around that time, consumers were predominantly people coming home from the war, leading military iconography and influence to become more prevalent in media. And makers of sci-fi increasingly came from the same crop, ex-military personnel familiar with war and the machines we used for it at the time. People were also getting more tech in their homes, meaning general tech literacy became high enough that you could no longer get away with fooling people as much on screen with a few dials and some magic button pressing. The audience would know it looked wrong. Simultaneous effects in sci-fi were similar. Filmmakers took audiences' increasing interest in social realism on board, and alongside the rise of production and distribution companies making higher budgets possible, this era saw film and TV develop more breadth across the board. Scientists also complained in writing to media companies about the magic science they saw on TV. Better production values and the hiring of expert consultants saw science fiction become more scientific than ever before.
So this is actually a letter published in a magazine that Isaac Asimov wrote to Gene Roddenberry, the creator of Star Trek, complaining that Star Trek was not scientific enough. He was complaining about the technology he saw, he was complaining the distances were travelled too quickly, all sorts of things. This letter actually resulted in Gene Roddenberry and Isaac Asimov starting to correspond, which made Star Trek more realistic in the latter seasons because they started to help each other.
They hadn't met at this point, I don't think. We can even trace this evolution by looking at Doctor Who. The Doctor's TARDIS console began as a quintessential example of nonsensical set dressing, but as Doctor Who evolved as a show with the sensibilities of the viewers, they became more consistent about which bits of the TARDIS console did what and the user experience it provided. Visual and spatial partitioning of tasks among different panels on his console created association, and people kind of grew to know what the Doctor was doing depending on where he stood.
So, the First World War and then the Second really, really strongly influenced science fiction. The returned servicemen that came home and the returned service women that came home or ceased their work in aid of war became consumers and creators of sci-fi, which resulted in stuff like this happening. This is Buck Rogers from 1939. That was the serial version. There's multiple versions of Buck Rogers for those who've seen the later one. This is the 1939 Buck Rogers. We've got fantastical future elements like the big view screen and contacting spaceships, but then when they want to actually talk to the spaceship, they go into the radio room to do it instead of using their big screen to do it. So they have a separate room where they go and radio the spaceship instead of using the one big interface they've got to contact the spaceship. And this is because military at the time, they had a radio room to contact stuff. They would go into the radio room. We still have radio rooms in military, but everything was rooted in the reality. It was a military metaphor. The two functions are separate because they're separate in the military, and the people making this had military connections. It's not as fantastical as it would otherwise be, it's because there's two pieces to the puzzle. 40s and 50s, we start getting more World War II style things. This is Forbidden Planet from 1956. The technology and interfaces in Forbidden Planet basically look like a World War II warship, but with a little bit of colour. It's not particularly interesting, but it's very similar to World War II, so it's just rooted in reality, as we said. At the end of the 40s and 50s, we start getting a bit more realism in terms of how UIs work instead of just resembling them. This is Destination Moon from 1950, which starts trying to think about how a real rocket ship might lay out its controls. So it kind of thinks about the position of the user and the position of controls and tries to map something to reality because consumers and viewers were more sophisticated. We start seeing controls and actions actually connected to the system's results. This is one of my favourites from When Worlds Collide in 1951, where despite the trend of mechanical controls in very early sci-fi being completely disconnected from the function they're meant to perform, this system's results shows the output of what the controls do directly next to the control. So these control like the vector of a spaceship, and you see the movement of the spaceship on the screen. This is very high-tech stuff.
We see the feedback loop getting tighter in these interactions, the cycle between the input and the output, while optimizing towards a desired state, becoming faster and faster. These mechanical controls kind of lasted a while, including the very influential Star Trek original series in the late 1960s. And they still pop up today when people want to give something a classic feel, everything from the mix of future tech and old-style console pieces in Interstellar to the retro looks of the Harder Goldbridge set in the Hitchhiker's Guide film.
So what can we learn from knobs and dials? Well, we think there's three kind of very important things you can learn from the knobs and dials era of science fiction. The big message here is a very straightforward one. Use what people know. By building from what people know, from the context in the real world they live, you end up making and imbuing users with the knowledge of how to use it. This is pretty much interaction design 101. It's nothing mind-blowing. Sci-fi is great at this because they need the viewers, readers, players to understand how something works in order to make sense of the story or enjoy the story. You don't want them to have to think too much. And again, when you're building a really complicated product with lots of interactions, you don't want them to have to think too much to accomplish something. No matter how complex what's going underneath, the overall explanation needs to be really simple. This doesn't mean skeuomorphism or like designing things to look like the real world. It just means use bits of the real world. Also tighten feedback loops. Make the result of something immediate and obvious, even if it's not actually immediate and obvious. Fake it if you have to. So we're not advocating that you make your UIs mechanical like this. This is a great example from Final Cut, the movie. It's really pretty. It's a great interface. It's highly specific for its use. So don't necessarily clone, wood textures or metal textures to do this.
It's called the guillotine.
It's called the guillotine.
But then suddenly, after decades of knobs and dials in sci-fi, we get to the beginning of a kind of modern second renaissance of visual sci-fi, where everything is flat. This came about for a few weird reasons. In the real world, we invented computers like this. This is the Aesthetes computer system.
Did anyone use one of these? Like, I've met a couple of people who've used one of these.
No? It's a CAD system from the late 70s, early 80s. Each function was given a separate button, but they were laid out in clean, logical groups. It was an actual, literal desktop of controls. This kind of interface that straddled the virtual and the mechanical didn't really catch on in the real world. The buttons had no depth, and they were part of a big membrane that spanned the surface of the desktop. Obviously, it wasn't a display, it was physical buttons, but it was a big step for the world, and especially the world of sci-fi. Because as it turns out, installing so many buttons on a set and individually lighting them, allowing them to be controlled, replacing them when the LEDs fail, as with the Star Trek original series, was expensive. So in solving this budget problem, designers on the show accidentally created an entirely new paradigm for sci-fi UIs, and it changed the way sci-fi looked forever. Touchscreens existed by this time, arguably being invented in the mid-1960s, but they were too expensive to be feasible for consumer goods by far. So as they began to emerge in sci-fi, it really cemented a sense of the story being in the future, where people could actually afford these things to be ubiquitous.
So flat UI, it impacted sci-fi big time. There's two really influential touchstones here. The first of these is Logan's Run, which was 1976. This is a favourite film of mine. It's really weird if you go back and watch it now. It has all sorts of weird gender problems, but it's otherwise a very good film. But it had a really unique computer. It had all the knobs and dials you'd expect in a science fiction film of its era, but it also combined those knobs and dials with a big screen that was basically a translucency that showed kind of a futuristic flat UI. It was really unique looking. It didn't look like much previous sci-fi. And that, arguably, combined with Aesthetes, the real-world product, led to something that changed how science fiction looked forever, which, again, is Star Trek. Star Trek happened again. Star Trek started doing away with the physical controls, the little glowy diamonds and things that were so expensive to construct and light, and came up with this thing called LCARS, the Library Computer Access and Retrieval System, which is horrible to use. People have tried to make this usable for decades, but it looks great. It's thoroughly and thoughtfully futuristic. It's very cost-effective because the set decorators can just print controls on sheets of plastic and swap them out on lighted panels. The ability to change the interface between shots by swapping the printed plastic also implied changing responsive controls. It was really powerful. It totally revolutionized science fiction. Sets looked amazing. They looked like the future. It looked glowy and fantastic, and every sci-fi sense owes something to this UI.
Flat surfaces also became pervasive in other media, especially in video games, since flat surfaces with flat textures are much easier to model than knobs and dials, and it's trivial to map player mouse input to touch input for the in-game system. And also from 1966 onwards, and doubly so from 1987 onwards, everything cloned, mimicked, and played homage to whatever Star Trek did. It was a huge cultural phenomenon. It still is, even to the people who might not know it so well these days. Star Trek is responsible for so much more than just the flip phone. And so from that day, everything, and I mean everything, in a post-LCARS world of sci-fi was flat.
Everything.
Everything was these big, flat, glowy dashboard touchscreens forever. Screens could be numerous, curved, or even holographic projections, but the interfaces themselves were flat. So visual distinction then became about what was on the flat. Dark backgrounds with bright colors to elicit a retro feel. You get clear screens or lighter colors for cleaner, futuristic. This is more akin to the aesthetic of real-world tech like the iPhone in recent years. This became what people thought of when they thought of the technology of the future.
So speaking of the future, on the typography side, in 2001 A Space Odyssey, which was made in 1968, we got HAL. HAL is influential for a whole bunch of reasons, which we won't really touch on here. But HAL was also surrounded by a bunch of flat UI on the screens of the spaceship. And this gets far less credit than it deserves for a number of reasons. I'm not going to go flat UI on you, but I'm talking about the typeface. So the typeface used on all the screens around HAL is called Eurostyle, and there's variants, Eurostyle Bold and Eurostyle Bold Extended. It's stretched, this stretched geometric typeface that you'll have seen in hundreds of movies since, right? It's everywhere. It's absolutely everywhere, from the sides of spaceships to future computers. It just looks great, and we're not exaggerating. This thing is everywhere. Nothing cements the future like using the font of the future, and we really cannot state how prevalent Eurostyle is. It's in all these films. It's in Guardians of the Galaxy, Moon, Hunt for Red October, Big Hero 6, Pacific Rim, Battlestar Galactica. Sometimes it's squashed, sometimes it's stretched. It's on the side of the Red Dwarf ship in the great British science fiction Red Dwarf. It's in Charlie's Angels, it's in Terminator, it's in THX 1138. It's literally everywhere. Everywhere. Wall-E, Jurassic Park, Iron Man, Prometheus, Robocop, the Lego movie. It's in everything. We were talking about how it was everywhere jokingly as we walked into the convention centre yesterday, and then we saw it in the sign in the convention centre. Right? It's everywhere. We're not even slightly exaggerating. Anything that wants to be slightly futuristic uses this Eurostyle font.
You'll see it everywhere now.
You'll see it everywhere now. Yeah, it's sometimes stretched or scaled, but it's always the same font. It was created in 1962. It's basically, since 2001, it's been the font of the future. We're not 100% sure what the lesson is here. We maybe think you should just use Eurostyle for all your user interfaces. You want people to think it's advanced. We're not quite sure. But realistically, we actually want you to think about what feelings and what experiences simple design components like typography evoke when given the context of established associations. It's really powerful. This is from Almost Human, the great TV show.
Cancelled.
Cancelled.
Before its time.
Cancelled, sadly.
So much of what we learn from this era is actually what not to do, because there's a clear distinction between design motivations from fictional ideals versus what studios could afford or thought to be established convention. But there are some important ideas here. Firstly, there is no haptic feedback whatsoever in these systems, or it's never suggested that there is, relying heavily on users to be fully sighted to properly understand what's going on. In the same vein, many examples are reliant on perfect color vision, spatial reasoning, and the ability to interpret moving images. Perfect for only the most able among us. As a total aside, this thing in the middle is called a Tesla suit and is actual tech from the real world, invented for all-over haptic feedback to accompany VR experiences, temperature, pressure, biometrics, and more. It can simulate weather and carrying things, the whole shebang. I stumbled upon it while looking for visual representation of haptics, and it's a solid example of how, even right now, we're trying to address how disorienting something is to interact with when it doesn't feel right. It's also hilarious that it looks exactly as absurdly obnoxious future tech as you would imagine, and also like that's the people who are going to use it. Such designs also undervalue the importance of muscle memory and general familiarity when it comes to the user experience of complex systems, such as in the common scenario in Star Trek where these highly expert users can't use each other's computers because they're so highly specific, contextual, and personalized.
So this is an actual scene from Star Trek. We didn't make these lines up. This is the great Worf, the wonderful character Worf, not being able to use his computer console to do something that he does every day because somebody has logged in and done something to it. Okay? So this is a problem we all have, I'm sure. But even Worf has this problem in the future.
The Great Worf.
The Great Worf.
Son of Moog. But the revolution of flat design in sci-fi also heralded in an important change in our world, multi-purpose controls. The idea that you could have one button with mode changes that either change the purpose of the button or show a totally different UI. This idea of fewer controls of many modes and easy mode switching is common in sci-fi and elicits a feeling of something being a specialist machine, or even that the user is a specialist user. But this idea has made it to the real world, even in our generalist machines, so completely that we don't even think of it. Like the fact that the A key on your keyboard can do A, it can do capital A, it can do special A characters, it can be combined with a control or command key to select all, and so on. Today our machines have a breadth of functionality that extends far beyond the number of physical controls they have. We don't even think about how that used to be the case. You had one button for one function. And another key point from this era is that when you have a distinctive original color scheme, typography, and general visual aesthetic, and stick to it consistently, you end up with a unique, differentiated expression of your product, experience, or project. It conjures strong association in your user base and makes for easier onboarding across services. A theme not really tied to one period in time is the concept of gestural and direct manipulation. This represents some of the most often cited examples of truly alien or futuristic interfaces that designers feel are still out of our reach. I'm sure the fans in the audience can guess what some of the common examples are going to be. But first, let's acknowledge the fact that a few real-world factors contributed to this trend in sci-fi media. Budgets and production design got better again, tenfold. Lots of money was being spent, but there was also more competition and pressure to be unique on screen. Film creatives wanted to test the possibilities. Experts began to emerge or become ubiquitous in related areas: graphic designers, interface designers, human-computer interaction researchers. The MIT Media Lab was founded, out of which a number of experts designed interfaces specifically for sci-fi media, among other more serious research. The iPhone and others popularized and normalized gesture-recognizing touchscreens, and the technology slowly and then very quickly rolled out to the broader public. And more tech became about recognizing natural human movement.
So how did this affect sci-fi? Well, there's some really early examples. There's The Day the Earth Stood Still, right? It's a very early gestural interface where Klaatu, the humanoid character here, interacts with his ship by waving his hand at the console. This is kind of related to the knobs and dials era, though, because what he's doing is kind of nonsensical and it just looks cool. It's not actually something that is useful. This was mostly ignored by sci-fi production design for a few decades there. Then we have Aliens in 1986, where Ripley controls the giant mech suit by waving her arms around in a giant mech suit. This is arguably not gestures, but it's definitely related to how gestures evolved. Star Trek got a holodeck, which is possibly all gestural controls, depending on how you argue how it works. Within virtual worlds, you're interacting with the system completely unencumbered, using gestures and every other facet of your body. Then there's Matrix Reloaded, which did it with armored personnel units in a similar way to Ripley's robot suit. We even had movies about Nintendo's Power Glove. This was product placement from the late 80s, but it's absolutely a movie about gestural controls in some respects. However, there's one that everyone usually cites at some point or another, and it's this one. This is arguably one of the most persistently and impactful examples of futuristic gesture-based controls in fiction ever shown on screen. It's the Minority Report from 2002, give or take. To many a layperson or a person who's not obsessed with science fiction or technology, Minority Report is synonymous with gestural interfaces. It looks great. It's really complicated looking. More recently, there's Iron Man, which presents the same concept. This has created two different associations held by two different age groups, depending on how old you are. But they're both landmark moments in cinematic interaction that have influenced designers way disproportionately compared to most other films and media. They're cultural touch points that gets returned to time and again when people think of sci-fi UI. It's really hard to avoid these. As it turns out, both of these UIs are actually co-designed by the same person. So this is a guy called John Unterkoffler, who was a PhD student at some point in the late 90s and then worked on Minority Report through the MIT Media Lab, and he founded a startup called Oblong, which makes systems like these a reality. Basically, his goal is to try and make this the real world. It's a bit out there, but it's working to some extent.
Gestural controls allowed users to provide input to a system unconstrained by conventional controls, with the free motion and position of their fingers, hands, and arms. And because of this use of 3D space, nearly all come with volumetric projection or projection of some kind, and this makes them look really cool. But even the Minority Report interface is nothing more than a great tech demo. In reality, Tom Cruise, the lead actor in the famous gesture scenes in Minority Report, actually needed constant breaks while filming, because holding your hands above your chest and moving them around constantly is actually exhausting. Not something you could reasonably do all day at your job, no matter how much it makes you feel like a Jedi. And we've known for a long time in the study of ergonomics and usability that's a terrible idea, though this strong argument lost against the rise of large desktop touchscreen monitors rolling out to the public in recent years. They're terrible for you. In addition, Tony Stark's are so overwhelming, it arguably only becomes constructive for work and research because Jarvis handles everything on the back end, so Tony can ignore a bunch of it and assume it will present what he needs at any given time. This idea of presenting what you need when you need it to unburden users already exists in the rising field of contextual computing research. A great intro to this is the papers by a colleague of mine, Professor Jesper Kjeldskov of Aalborg University. He talks of the need to make interfaces less complex by making them contextually sensitive, to know where you are and what you're doing so you can guess what information or functionality you'll require next. But really, Projections and gestural interfaces are everywhere in sci-fi. Everything from video games showing projected interfaces within the video game worlds to interactive holograms in movies like Treasure Planet, so cool. Interactive, projected, usually holograms are almost stand-ins for touchscreens in sci-fi at this point. There are some interesting and varied examples of this kind of interface, spicing up a range of films, and sometimes they're good. They're at their best when they show one thing with one idea, something that would be difficult for the user to comprehend or interact with in 2 dimensions. Selecting a point in a 3D sparse map, inspecting a complex 3D object, navigating 3D space, or just having a more conventional control interface that can change context as fast as refreshing a hologram. But some of them are not so good, like the designer from Prometheus who decided that a flat surface with a bunch of text, image, and video information would be more useful as a yellow cube. But for good or evil, these sorts of things can be made today. The release of the Xbox Kinect especially was a catalyst for more people to start tinkering with these types of gestural interfaces. It was no longer about getting access to obscure devices from high-tech interactions labs. Some very quickly realized the Tom Cruise problem, but most people are catching on, and there are more alternatives by the day.
So we're really not here today to talk about this kind of UI, at least not on the technology level. We're not here to talk about how neat room-scale projections and room-scale gesture recognition is. It's neat. We know it's neat. It looks great. We're here to talk about the meta lessons, what you can get out of the little details, the ideas from sci-fi like this that will help you make better, more interesting things when you're doing really complicated products with today's mass technology. So systems that behave in straightforward ways and imitate reality really show steps towards creating a great user experience rather than something fantastical. In our fiction, there's a human need for a system that responds to the way humans communicate and interact and instruct, rather than having to learn more difficult ways to interact with more complex technology. So it's really great when these gestural direct manipulation interfaces are basically designed for recognition, because when something looks like the thing you think it is, it's much easier to remember what it does, because you're like, that's a circle, I can turn that. When you're recognizing stuff rather than recalling stuff, the brain has a much easier time of doing it. You know what you're doing because you're grabbing or waving directly at the thing you want to work with. There's less abstractions in the way. The iPhone knew this from the get-go. Lots of other touchscreen devices kind of knew this from the get-go. It actually took longer than it should have to catch on in the real world. Presenting things in 3 dimensions also helps because people love positioning. People have really good memories for where things are positioned in the real world. There's no need to remember how something works if it's always in the same spot, and it's something that obviously does the thing it looks like. So this is the same principle as everyone kind of knows how to use a door handle, no matter how the door handle looks. You know to grab it and turn it or spin it. Affordances become obvious if they look like how they move or work. Right? There's a great book, Design of Everyday Things, that kind of covers this, but it's pretty common. Complex interfaces should only be used when the information makes it so. So don't make information complex just by putting it all in one interface. Sci-fi is actually really good at doing this properly, believe it or not. 3-dimensional interfaces, likewise, should only be used when the information or required interactions are also 3-dimensional, not just because it looks cool. Simplicity is always preferred.
Voice interfaces are also commonplace in science fiction. As far as we know, the first voice interface shown in sci-fi is actually in Metropolis again in 1927. The evil robot Maria gets woken up and commanded about using voice.
This movie's way more influential than it should be. Go watch it, it's great.
Or when Klaatu shouts at Gort to stand down in The Day the Earth Stood Still in 1951. And I apologize for harping on about how influential Star Trek was. You might be catching on by now that we're a little biased. But in several iterations of the Star Trek computer there have been over the years, each had the same prominence of voice interaction that made it the show of talking computers. It hit this idea hard. There are a broad range of other examples of voice interfaces in media, even beyond sci-fi entirely. As with gestural interfaces, speaking of underlying user desire for more natural interactions, the spoken word is the most natural instruction set people can think of for most things. But few go beyond the concept of the magical machine that can understand the meaning and context of all human language without restriction, basically magical machines, and these cases are unrealistic at this point. But this is a scene from the Star Trek original series, an episode that aired on the 6th of December 1966, 53 years ago. And Kirk suspects a man from a visiting acting troupe to be a famous murderer. If anyone remembers this episode, it's really good.
Feel conscious of a king.
Long thought dead. He interrogates a computer for information. Reading the first line, he says, "History files. Subject, former Governor Kodos of Tarsus IV, also known as Kodos the Executioner." After that, background on actor Anton Caridian. He carries on executing a complex compound query that leads to him comparing and drawing similarities between the biographies and photographs of these 2 identities from a single conversation with a computer that took about a minute. Blade Runner has an even more compelling example of this, arguably. Deckard investigates a set of special photographs recovered from a hotel room. Though these photographs appear 2-dimensional, they contain 3D information captured at the moment the image was taken. To examine them, Deckard inserts the photos into a television-like device called an Esper machine, then speaks a series of instructions that are short and direct. Enhance, pull back, stop, go right, etc. The only time he uses a full sentence that sounds somewhat conversational is at the end of the scene. Give me a hard copy right there, he says. And in response, the machine prints the part of the image shown on the screen. The thing about examples like this is that upon closer inspection, or maybe not even then, these characters have clearly been trained to speak to these computers. Each sentence he has is a discrete request for information, a single command like a glorified SQL query, or a single action as if acting like a button himself. This sounds like something natural language experts have been wishing in their fever dreams for decades. If only the humans could be trained to adhere to the grammatical rules they defined, our job making computers understand them would be so easy. But the thing is, this is starting to happen today. Children are training themselves to use Siri even more effectively than adults do, because there's a positive feedback loop. If you ask something the way she likes, she will understand you, and if she understands you, she will do as you asked. So if you got what you asked for, it's like a reward for asking the way she likes, and if you didn't, then your experience became a subconscious disincentive for the future.
So what can we learn from all this? What's interesting about sci-fi's treatment of voice? Well, obviously, establish a clear, concise vocab. For all the whiz-bang things shown in sci-fi, it also shows us the reduced vocab is a really good idea. Reduced vocab increases recognition. That's been known for decades. Even if your system can technically do more, allow it to work with less, and even encourage it to work with less. This is an actual screenshot. Well, we faked it after we did it, but we realized at the time it was a great example of me trying to set my alarm the other day after I stayed out slightly too late and wanted to get up in the morning to rehearse the presentation. I shouted at Siri to wake me up at the ungodly hour of 6 a.m. And of course, Siri dutifully set an alarm for me for 6 a.m., but it just ignored all the garbage of me complaining and set an alarm. It ignored words and outside of the vocab effectively. It just did the right thing and set my alarm appropriately. This was great. Another lesson is, especially as Star Trek shows, that even hundreds of years in the future, voice recognition will never be perfect. This is a scene of Chekhov, who has a very strong accent in all the variations of Star Trek, trying to talk to the computer. This is a common accent, it's nothing special, but because he pronounces words a certain way, the computer does not understand him, and he keeps trying over and over again. This is an accessibility issue, and it's all too real. Don't make your voice recognition interface work like this, and don't assume audio input is flawless. Provide other means for accessing things. Siri, for example, has a Type to Siri feature on all of Apple's devices where you can just type and talk to Siri. And Google Assistant, arguably the original Google search engine, is the Type to Query interface for that. Make sure there's multiple ways to do things.
Our next theme, which sometimes exists alongside others we've mentioned, is anthropomorphization, which I'm sure I will stuff up at some point. Humans naturally anthropomorphize everything, from appliances to pets and everything in between. This is particularly prevalent in science fiction, and also with my mother-in-law, who paints pictures of our dogs. Anthropomorphization doesn't require something to look human. Humans are very good at giving human characteristics to things that aren't even slightly human or only very slightly human. Tony Stark's robot arm dummy from the Iron Man films has a lot of human-like gestures, which makes Tony relate to it in a very human way, so it seems like it has a personality. There's even a cocktail-making robot down at the expo hall, if anyone saw it yesterday. I got a Negroni, it was great. It has a bunch of gestures that it doesn't really need, that are more like how a human would make a cocktail than how much more effectively a robot probably could. But it makes it easier for us to enjoy it. It does the flair. Humanness is transferable to non-human systems. It's very easy. Humans do most of the work for you when they look at something. Only the barest hints of humanity are needed to make humans project whole bunches of social, societal, emotional, and physical baggage onto something and anthropomorphize it, even when you don't want them to. Conversation, particularly, even in the most basic implementation, casts the system in the role of a character. And this is Danger Boat from the Tick TV show, so like the new one, on Amazon. Danger Boat has this little camera that moves around through channels on the roof, this spherical thing you can see, from which his voice output sound appears to originate. He converses like a human, despite a robotic-ish voice, and viewers quickly get the impression that Danger Boat controls the boat, rather than is the boat. In fiction, this allows for technical characters with the abilities and resources of a machine, but that viewers still empathize with. Marvin from any incarnation of The Hitchhiker's Guide is a great example of this, as is Holly from Red Dwarf. They're just characters who happen to be machines.
Non-linguistic sounds used expressively are great ways of triggering anthropomorphization. You can anthropomorphize without a voice. Star Wars does this really well. All the robots in Star Wars that don't speak are great at this. The biggest motivation for employing this tactic in the real world is that people may be more forgiving of imperfect execution of something if it's kind of human. They'll feel sorry for it, or they'll feel sad for it, or they'll want to support it. But it can backfire. It can go very wrong. A great example of it going really wrong is Clippy. from Microsoft Word back in the day. Clippy has a big clear mismatch between expectations and reality in terms of the behaviour of the agent. Clippy was annoying, presumptuous. It transgressed social norms. It was ridiculous. It behaved like a person, an annoying person. You would hate this person if this was a person. It was a really bad example of this, but it's also a cautionary tale. The more human something seems, the more expectations are placed upon it. Clippy's the perfect example of something doing that poorly. But anthropomorphization is really hard. It's terrifyingly hard. Use them wisely.
Next up, a very quick diversion into brain interfaces. After the invention of EEG in the 1920s, the rise of medtech happened and everyone was enthralled by the possibilities. By the 1960s, an American composer used an EEG to control signal processing hardware, produce alpha waves, and control the music in one of his pieces. A few years later, a UCLA professor coined the term brain-computer interface, or BCI, and everything took off, both in the real world and in media. There are many examples of this in science fiction, from brain interfaces that control conventional computers to automatic mind control of agency in virtual environments. But we're going to gloss over this bit, because there's really only one lesson for now. They've made great strides in this area of research. Lots of very clever people have worked very hard, and there are even working products out in the wild doing great good, particularly for people with restrictive usability needs. But for the general public, many feel they're intrusive to the extreme. They'll probably be great once we can implement and control them better than we can right now, and use them for very specific things.
Okay, so let's wrap this up. We've looked at a bunch of themes that exist throughout the world of sci-fi. There's a lot more out there. We could talk all day, but there's beer, apparently, to get to. So we're going to talk about some quick lessons for the future. First lessons, when you're thinking about science fiction, sci-fi is not a usability manual. It's not a magic way of looking at the future and saying, this is the future, I shall now build it. Sometimes that works, sometimes it doesn't. It's not a magic solution to your interface design needs. It's just a really good resource, particularly because it shows a lot of AI, big data-driven, complex applications that most of us are probably trying to build in the real world. There's definitely a cycle of inspiration between the real world and sci-fi that definitely exists. We should look at that and think about how that affects our work. Sci-fi sets expectations for users and creators and consumers, and there's a big loop. If you design an interface that looks like something people have seen in science fiction, people will expect your interface to act like the science fiction that they've seen it in. You're kind of beholden to the first thing that showed something similar, so you really owe it to yourself to know about it if you're building something that humans interact with, especially something futuristic. Sci-fi is just a tool, though. Think about it with a critical mind. Don't just look at interfaces, consider interactions between AI and objects and people in sci-fi and all that stuff. Stop watching science fiction and start using science fiction. Observe it and watch it. This is a great quote from Sud Mead, who is a designer, designed Blade Runner, Aliens, Star Wars, Star Trek the motion picture, and almost everything in between. He was a ridiculously influential designer. Science fiction is reality ahead of schedule. It's one of my favourite quotes about this.
The second group of lessons are on the interface design side. Interfaces that operate on behaviours people already know mean they have to learn less to use your system. More natural behaviours, less learning. Many sci-fi interfaces portray this deeper desire for systems that respond to the ways we communicate already, without having to learn a whole new set of interactions that will change as quickly as the technology does. Systems we can speak to, or that present visual representations that feel like what they look like, or whose required form of interaction maps to the task being performed with it, feel more intuitive. They allow users to start from a higher skill level, and this makes them feel powerful, useful, and makes them more motivated to use the system in the future. Right now, in the real world, users of technology are basically playing a game of pretend to be a cursor that we're not designed to be very good at. In sci-fi, users don't have to project their consciousness into this flat, little, dull, minimally colored world in a box. You don't need to be making fancy, complex AR, VR projections, whatever, to do this. Just working on design from a perspective closer to the real-world interactions first, rather than accepting whatever is convention at the time, can do wonders. A rectangle with a text being touched to make an action occur somewhere else may be convention, but that doesn't mean it's the best we can hope for. Doing this well means balancing spectacle, meaning, and utility all at once, and it's no mean feat. And in the same way that film UIs benefited from bringing in scientists and communications experts, you can too. People have done this work, or their research, at the very least. Organizations like the MIT Media Lab and its various incarnations, and the people involved in those sorts of entities have known this for decades. Design conventions don't necessarily exist because we haven't effectively proven they're a bad approach. We have, in many cases. Interaction research is crucial, but so is listening to it. Thank you very much.